I think the academic world has realized that pretty much any assignment that you give your students at this point can be completed by an AI tool. There may be a few exceptions, but for the most part, the capability is there. So it's time to figure out how are we going to address this. In this video, I'm going to talk about the show your chat history method. So this is a transparent way that students can choose or opt in to use AI tools. And then when they submit their assignment, they share the AI chat history as well. There's a lot of benefits of this that I'm going to go into in this video. This is the central thesis, and I believe that by having the dialogue with the AI chatbot, being able to ask questions at any time, dig as deep as you want to, hopefully exercise the critical thinking skills, the students are going to have improved learning outcomes from this increased engagement. It's been shown that students do better when they are more engaged, and that engagement could be in the form of interaction with instructors. It's actually more effective when they interact with other classmates. But when it's 11 p.m. and they're sitting down to look at their homework, those people, generally speaking, are not around, although I guess their classmates could be online. But an AI tutor is available 24/7, and you can always talk to it. It'll never get tired of answering your questions. That's the great thing about this. And again, I think creativity and critical thinking, asking questions, having the Socratic dialogue is really one of the keys to learning. It's certainly how I do it, and I think it benefits a lot of students. Before we dive into the method, I wanted to say a quick word about AI in general. So this gives important background and motivation when you're considering how to use AI in your classroom, either as an instructor or a student. So in general, software is solving some problem with which generally here we're showing as some function f. It takes a series or set of inputs x, and it's going to give you an answer. Now, for a long time, classical software, what I'm calling, we code the rules and the logic explicitly. So if it was an accounting system that we're talking about, we would put in the logic and the rules for how to handle debits and credits, and you would get your system, which would produce your financial statements, all the other outputs. In the case of AI is really, the foundation is machine learning. And in this case, we don't explicitly tell the computer what to do. We give it lots of data and examples. A lot of times this is in the form of either a question and an answer or information statements that is labeled or annotated. Essentially, we're giving it what we call supervised learning. So here are some examples. Go learn what the patterns are, and we build AI solutions on top of that. So it figures out what the implementation of that function f is. And historically speaking, that function started out small. So initially it might have been optical character recognition. Given an image, which is a handwritten character or number, tell me which alphanumeric character that is. Then we go, like, for example, 1997, Deep Blue, the IBM computer beat the reigning chess champion, Garry Kasparov, in a 6-game series. So those are very specific domains in which AI solutions performed really well. Now, if you think about IBM Deep Blue, although it could beat you at chess, it couldn't really do much else. It couldn't recommend a movie for you to watch on Netflix or do anything else that we consider AI today. So those were narrow AI solutions, or what some also people call weak AI. Now that's going to contrast that to strong AI, which exhibits more general intelligence. Now, generative AI solutions, which have become more popular since late 2022, the introduction of ChatGPT. You also have Google Gemini, Anthropic's Claude, and others. These are large language models, large because they've been trained on vast amounts of text, all of the pages of Wikipedia, open source book collections. And the way that they train, when they start out, they know nothing about language. They're basically going to take blocks of text, blank out one of the words, and then make, at that point, essentially a guess as to what that blanked out word should be. It'll be wrong, and then it'll adjust the probabilities in its model and continue doing that, going and going through all of that text. And by doing that training, it can learn the patterns that are in natural language. And this is why it's so good. This is why in some studies, over half of the time, today's AI chatbots can essentially win the Turing test, meaning that someone who is talking or a chat interface would not be able to tell, am I talking to a human or a machine? So they're quite good at language simply by learning from the data. One of the breakthroughs in LLMs is the attention mechanism. So it can be more efficient because it looks at your input prompt and decides what words or tokens are more important to focus on. In particular, it also looks the relationship between the terms. So in my prompt here, what is the capital of Florida? This is a notional diagram, of course. It shows that the words capital and Florida are more important, and it'll use that to predict and generate the output. The capital is Tallahassee. So every token it predicts, it uses that in addition to how it's encoded your prompt to generate more and more tokens. This is why it does happen sequentially, and you see the output for most AI chat tools being streamed to your web browser. Now, there is an ongoing debate about whether these large language models are actually intelligent. So one camp, critics would say, well, this is really just statistics and recognizing patterns in language. It's like a fancy autocomplete. Other proponents of AI would say, well, by generating these tokens and basically thinking through the syntax of language, you get emergent intelligence, that it's actually able to reason through that process. And this is actually a key technique that I also teach in my prompt engineering class, which is the chain of thought. One thing that you can try if you're working with an AI tool and you have a complex problem that you want it to solve, just add the sentence "think step by step" to the prompt. Oftentimes this will improve the performance. Now, if you can explicitly state what steps you want the AI to go through, that's even better. But the idea here is that the LLM is forced or directed to produce more intermediate tokens in the output. And by doing that, you're increasing the probability that by the time you get to the end, you will have statistically arrived at the correct answer, or at least a quality answer. So there is some rationale or intuitiveness to this, I suppose. So if you had asked me at the beginning of this presentation, Darren, talk about what's on slide number 7, I would have to get myself situated as to what I'm going to talk about and think about that. Now, it might not be as good as if I'm naturally giving the presentation, going through slides 2, 3, 4, 5, I'm going to flow right into that step 7. So intuitively, this does make sense, but there is an ongoing debate about whether this is actual intelligence or merely statistics. Finally, one last thing. Professor Ethan Mollick of Harvard Business School has what he calls the jagged edge or jagged frontier of AI. And the point here is that as good as AI is, it can do a lot of things, but sometimes it can't answer a prompt correctly. And it's difficult a priori to know which case you're in. The arc in this diagram, there's a number of tasks that are marked that are really of equal difficulty, but some can be achieved by today's AI and some can't. So it's really good to always, if you're using AI in a classroom, to try out some of the problems ahead of time, or if you're able to train or prepare the system with that information to do that. So let's now transition to the current state of the world with AI in education. These are two recent headlines. The first is a study that came out, and there's limited data because generative AI is so new, but we're starting to see studies now. This Harvard study, this was an intro physics class, and the students reported better learning outcomes because they felt more engaged. They were able to interact with the AI tutor and dive deeper into many of the concepts in that class. Now, the opposite is this study below. This was kids in a math class. They used an AI tool to help on their practice work. And what ended up happening was the group who used the AI tutor did about 17% worse on the exams. The reasoning for this is because they believe the students became overly reliant on the AI during practice. They scored excellent on the practice assignments, but they didn't learn the fundamentals, the mechanics themselves, and that showed on the exam. So this is a good synopsis of the pros and cons of using generative AI in classrooms or in coursework. You want to get the engagement out of it, but you don't want to build the over-reliance. So that's what we're going to focus on next. For this reason, many teachers are concerned about AI in the classroom. You can see that there's really only 25% of teachers think that they're going to cause, or I should say 25% of teachers believe more harm than good is going to come from these tools. So there's a mixed reaction. And you can see on the left, so institutions that have tried to ban generative AI, over 2/3 of teachers are distrustful of whether student work is actually theirs. At schools where it's not banned, it's still almost half. But banning AI is probably not enforceable. I don't think it's a good long-term solution either, because you rob the student of the ability to learn these tools that are going to be prevalent in the workforce when they get out there. So you're going to want them to have that ability, have that intelligence to leverage these tools, because everyone else in the workforce or in different fields of study are likely going to be using them also. In this survey, we see that over half of teenagers say that they use AI to help with their homework. In a Pew Research study, I believe the 10th through 12th graders, it was 46%. In general, you're seeing about half of students reporting using AI to help with their assignments. Overwhelmingly, it's ChatGPT that they're using, but this is not going to go away. So it's something we want to have a good approach and know how to deal with. Many instructors do use AI detection tools, but for the most part, the recommendations that I found recommend not to use those. I know that Purdue University, Duke University are a couple of institutions in their policies. They recommend against AI detection because they're not reliable. In fact, for this very research, I wrote one of the paragraphs I wrote for my chapter, I gave to two different AI detection tools. One was convinced that it was from a human, and the other was convinced it was from an AI. So, and LLMs are just too good at writing text. As I mentioned before, they're passing the Turing test on an increasing basis. So I think other than knowing the history and the characteristics of your students and seeing, okay, this looks out of the norm for them, there really won't be a reliable way for teachers or instructors to know whether a student used AI. Now, in the post-AI world, the World Economic Forum has a paper here where they talk about what are the most important skills going forward, specifically 2027, but in general. Now, at number 3, you have AI and big data, which clearly is important, but look at number 1 and number 2, analytical thinking, which I think also overlaps with critical thinking, and then creativity. And to me, this truly resonated. I worked at Amazon for 5 years, and Amazon has leadership principles that really get used every day. It's pretty impressive. And the two that resonated, or the two biggest ones to me, were learn and be curious and dive deep. And those kind of align with these two top skills here. I think those are really crucial for being able to succeed in a post-AI world. So instructors, to the extent that you can always look at how to incorporate that in your curriculum, in your classrooms, it's going to be truly important for students going forward. Now, when you start out with a problem, it generally follows this pattern. You look at it, you don't know yet how you're going to solve it, so you're brainstorming. You're doing what is called divergent thinking, coming up with different ideas, evaluating them, doing research, figuring out, learning as much as you can, figuring out, okay, what path am I going to use to get to a solution? At that point, you're going to start to converge and eliminate possibilities, confirm your knowledge, and decide on a path to get to the solution. How do students do this? Well, a lot of times this research can happen by doing a Google search, but increasingly now it's happening through AI tools. So like we mentioned before, you can have that ongoing, always available conversation or dialogue with an AI tool to ask these questions. I do this all the time when I'm working on a problem. It's not quite like having a conversation with yourself, even though it's just me and the AI tool, but you're getting the feedback. You're getting different answers, sometimes that you might not expect, and it's forcing you to think in different ways about a problem. It truly is helpful, and I do it quite a bit, and I think that as students increasingly, they're already using the tools. If we can get them to use the tools in a way that promotes that level of engagement and critical thinking, that's really going to be a net positive. So we want AI to be the active learning partner. It certainly is not a replacement for the basic skills like we saw in that math study. That's not going to work. So students can't just ask for the answer. That would not be a passing grade. I show this use case at the bottom. So what you really want is AI as an assistant. Most of my career up until recently has been as a software engineer. So AI is great at generating code, but you need to understand Does the generated code solve the problem correctly? Is it doing what you want? Sometimes there might be a bug in it. It might be a reference to a non-existent library. That can happen. But you also may not understand the requirements until you're actually going through this exercise. In summary, you need to still understand coding and information technology to use what's being generated. And that's, I think, really true of almost any domain in which you're using AI. You need to understand the fundamentals to apply the output, to verify the outputs, and then to correctly apply them. Now, as a bit of practical advice, if you're using AI for education, I think you want to use a tool that is configured for that purpose. So in doing this research, I asked ChatGPT to help me solve a linear programming problem. This was essentially an optimization problem with two variables in a manufacturing scenario. ChatGPT proceeded to give me every single detail, every step, all the way up until almost, I believe, the very final answer. Now, if I'm just trying to solve the problem, that's great. But if I'm a student trying to learn, I don't want that. I want to actually go through the critical thinking process myself. If you're just using Google Gemini, the default commercially available tool, that is much better at going step by step. But your best bet is going to be to use a chatbot focused on education. So Conmigo has a GPT builder available, and I believe this is available even if you don't pay for a ChatGPT subscription. I have the picture here. It's called TutorMe. It does quite well. I'm going to walk you through me using this on a geometry problem. So this is an assignment. We're asking the student to prove that the sum of the interior angles of a triangle add up to 180 degrees. You can use an AI tool to do this, but document your reasoning, explain your usage of the AI tool, and then you submit your proof along with your chat history. Now this could be sharing a link, which most tools have, or they can copy and paste it into their submission. So here I start out asking TutorMe for help. And it says, yes, we can do that. The first thing it prompts me about, what do we know about a straight line? So there's multiple ways to configure or to go ahead and create this proof. The most common would be starting by drawing a perpendicular line to the triangle and using the fact that a straight line is essentially representing 180 degrees. So it's not giving me the answer straight away. It's forcing me to think through and kind of hinting at what are the axioms that I would need to construct this proof. So here I go ahead and answer that question. It confirms that I was right. And now it's going to point me in the direction of the alternate interior angle theorem and kind of the next axiom, the next building block I need to put this proof together. So it's doing a good job. I did also try just saying, I don't know, trying to give a response that would represent me not putting in much effort. And it does continue to ask questions. It does a good job about that. Now, if you're wondering what is the actual proof, I'll save you some time. I've got the diagram here. You can see that along the perpendicular line DE at the top that we drew, A plus B plus C is 180. And then with alternate interior angle theorem, we can show that A on top is equivalent to A within the triangle. Same thing with C is the same as C on the interior of the triangle. So A, B, and C interior angles do add up to 180. Okay. Now, this dialogue that you're asking the students to have with AI, some of them, they might not know how to begin. What does that look like? So a recommended structure would be what, why, how. You would begin by asking what questions. So this is the divergent thinking process. What type of ideas or techniques should I be considering to help me solve this problem? You can see in the TutorMe example we just looked at, that was going on. What are the axioms that I would need to put this proof together? Number two is a really important step. So I may be pointed toward those building blocks I need, but why are those helpful? Why would I apply those here? Why would they be better than a different technique? In the case of the proof, there are other options, so you could compare those. But this gets to the true understanding of what we're actually doing here. It's one thing to know the mechanics, but if you don't know why you're doing those, you're not going to get nearly as much out of the class. Finally, if students are struggling then to apply that, you can move into how questions. Okay, I know that I need the straight line, 180 degrees axiom, and I also need alternate interior angles. But if the student still is struggling, they can ask questions about, okay, how do I use these to arrive at a solution? This here is an example, a different use case. This is a creative writing assignment that I use in my prompt engineering class, where they're tasked with creating a short story that they're going to use AI to help them write. So they're required to share the AI chat dialogue that they used to help with that story. Another important point is they're asked to write a short reflection on that process. So how did AI help them? What were the pros and cons? And as a part of this, we set up that we gave them the patterns or templates that they could use, whether the AI would help them with the plot or character definition or elaborating on the setting for the story. There's any number of different ways that they could do this. But the key is it is their work, it's their thoughts, but it's AI assisted. Now, you can also, if you choose, evaluate the actual chat histories as well. This is the transparency into what is the thought process and the learning process to a large degree. So you want to see that level of effort. If they're only asking, and I've seen this, asking a single question, write me the story about a cat on a rocket ship going to the moon, and they just take what they're given, that is kind of minimal effort. I've also seen some very good student chats where they elaborate, ask follow-up questions, change aspects of what the AI is giving them. That's the level of engagement that you want to see. You don't want to see just superficial questions. You want to see them gaining insight, probing, asking more critical thinking questions, and even challenging sometimes. We know that AIs can hallucinate and give incorrect answers. So pushing back is something that is a good thing to do, especially if the student or you question what you're getting. I've certainly done that. And in some cases, yes, AI does make mistakes and it will admit, oh, you're right, that this is incorrect. And here's the corrected version. And then finally, the exploration and reflecting on the process are all things that you can do to evaluate how effectively a student is using these tools. Now we get into some really exciting stuff because with AI, there's a lot of things we can do now that we could not easily do before. How about conducting a science experiment? So when I was in elementary school, I did a science experiment like this where I compared plants that had music played to them every day. In my particular case, it was the Def Leppard Pyromania cassette, which I happened to be a fan of at the time. I listened to that so many times, those plants did grow better. But all of that takes time and effort. The great thing about AI is not only can it help at the beginning, it can help students ask those questions and come up with what would be a good hypothesis for me to test. Once they decide on that, well, how could I set up an effective experiment to test that hypothesis? And experiment design is important. So those are good ways the student can engage with the material. Finally, data simulation. And this particular example here was about plant growth under different light conditions. ChatGPT generated or wrote Python code for me that I could use to simulate the data under those conditions. So I'm able to really go through the whole scientific process rather quickly, and every student would be able to do this on their topic of choice. And then, of course, the analysis and conclusion, and that ties in then being able to write and communicate your findings. Now, this paper is extremely interesting to me. These researchers use language models as subjects in a social study. So they have, I think, 5 different ideas or 5 different use cases that they evaluated. Very exciting stuff. This opens up a lot of possibilities once more. I apologize for the slide overlap here, but basically this particular simulation is what are the factors that lead to a judge setting the bail for a defendant? And the factors, as you can see here, are the defendant's criminal history, whether they are remorseful, and how many cases they've had already that day. They ended up creating a structured causal model. You can see the math behind that on the right side, but effectively they were able to simulate this social experiment and conduct studies all with the help of AI. Very exciting stuff that students can do in this type of setting. So where am I going with this research? I'm going to continue to evaluate different AI tools, perhaps do some construction of my own with what's out there to better support this. Certainly the Conmigo Tutor Me GPT is a great way to start. That's already available now. And then I will be conducting studies in this upcoming year to put this into practice, giving students in select classes the option to use AI to assist them in doing some of their work. Thanks so much. I hope you got something out of this video. Please leave a comment, like, or subscribe, and we'll see you next time.